Your manager just said, design the payment system. And if you start on the wrong side of the screen, you can waste weeks. Do you draw boxes and arrows between servers? Or do you start writing Java classes? If you have ever frozen at that question, you are not alone. Most developers do not know where the line is between big picture design and code level design. By the end of this lesson, you will know exactly when to draw boxes and when to write classes. Let's use a restaurant analogy. High level design is the restaurant floor plan. Where is the kitchen? Where are the tables? Where is the entrance? How does food flow from the kitchen to the table? This is about components and communication. Low level design is the recipe book. How exactly do you make the French fries? What ingredients? What steps? What equipment? This is about internal details and implementation. A floor plan tells you the restaurant has a kitchen. A recipe tells you what happens inside that kitchen. See the difference? One zooms out, the other zooms in. Here is a concrete example with a payment system. On the high level side, we ask, what components do we need? The output is an architecture diagram. For example, the payment service talks to the Stripe API through a message queue. On the low level side, we ask, what classes and methods do we need? The output is a class diagram and code. For example, a payment processor interface with a Stripe processor and a PayPal processor behind it. In interviews, high level rounds ask, design Twitter at scale, think databases and load balancers. Low level rounds ask, design a parking lot in code, think classes, methods, and patterns. This course is 100% low level design. We are going deep into classes, interfaces, patterns, and Java code. Quick question. Someone says, we need a Redis cache between the API and the database. Is that high level or low level design? Pause for a moment. This is high level design. Why? Because this sentence is about where Redis sits in the architecture between the API and the database. It is not about class code. Think of it like this. High level design is adding a new room to the house. Low level design is where is the switch in that room and which wire controls which light. So adding Redis between the API and the database is high level. A cache service class with get, put, and evict methods is low level. If you got that right, you already feel the difference. Let's see it in code. Now let's see what happens when you skip low level design. Imagine someone says, design a notification system, and you just start coding without thinking about classes, interfaces, or structure. You end up with one class and one giant method. Everything is jammed together. Email logic, SMS logic, and push logic all in the same place. Want to add Slack notifications? You add another else if branch. Want to change how email works? You have to open the same method that also handles SMS, and you might break it by accident. You had the big idea, we need notifications, but you skipped the code level design. Here is that code. One class, notification app, one method, notify. It takes a type, a message, and a recipient. Then it checks. If the type is email, send an email. Else if the type is SMS, send an SMS. Else if the type is push, send a push notification. And each branch hides about 30 lines of its own logic. One class, one method, everything tangled together. Every new channel means another else if, and every edit risks breaking the others. This is what skipping the design step costs you. Now let's answer the 3 low-level design questions from lesson 1. What are the things? A notification, an email notification, an SMS notification, and a notification service. What can each thing do? Each notification type knows how to send itself. How do they connect? The notification service talks to any notification through one shared interface. Draw it out. The service points to the notification interface. email notification and SMS notification both implement that interface. The service never cares which one it is holding. That means adding a new channel does not touch the existing ones. Here is the code. First, an interface, notification with a single send method. Then email notification implements notification and defines how an email is sent. SMS notification implements the same interface in its own way. Finally, the notification service holds one notification, whatever it is, and calls send on it. It does not know or care whether it is email or SMS. That is low level design, specific classes, a clear interface, and injectable dependencies. In about 15 lines, we support email, SMS, and any future channel without changing existing code. Want to add Slack? Create a Slack notification that implements notification. Done. Nothing else changes. That is the difference. High level design says we need a notification service. Low level design says here is exactly how it is built. Your turn. Your product manager says we need a cache service that wraps Redis with get, put, and evict methods and deploy it behind the load balancer. Which parts are high level and which are low level? Where is the line? Take a few seconds and decide before I show you. Deploy it behind the load balancer. That part is high level. It is infrastructure and system architecture. A cache service with get, put, and evict methods. That part is low level. That is class level design. The manager's one sentence contained both. And in real projects, the line is never as clean as a textbook makes it look. Let's lock in 3 ideas. 1. High-level design is about system components and how they communicate, boxes and arrows. 2. Low-level design is about the classes, methods, and relationships inside each component, Java code. 3. This course teaches low-level design, the skill tested in design interviews and used every day in real code bases. To do low-level design well, you need to think in objects. And that means mastering the 4 pillars of object-oriented programming. Starting next lesson, we tackle the first one, and I will show you why exposing a public field is like removing the guardrails on a mountain road, where every bug and every bad value gets a straight path to corrupt your data.